Okay, welcome back. This is the review for test 3, and I want to go through, give you a good question poll, and remind you what is sort of required from you for this section. Okay, so chapter 7 is where we are, basically Laplace transforms. I'm not giving you any notes on the test, so you're going to have pretty much all this stuff memorized. I won't give you anything like a transform of a hyperbolic sign or something weird like that, or force you to remember the inverse Laplace transforms of a product of a function with t or something, where you have to like remember, oh, this is the derivative of this, and then you can. So you should be able to handle all this sort of without notes, is my point. Okay, the problems will be set up in the same way the problem is set up in your homework. So for example, 7.1 number 8, I'm asking you to use the definition of Laplace transform to determine the transform. Okay, so for example, here we have a Laplace of e to the negative t sine t. And the way the question is written, they give you the definition and the question. So on the test, I'll also give you that as well. So it's just like homework. Okay. All right. So anyways, the Laplace transform of this, of course, from definition. So you can't just write the answer. You have to show me the work if you're using the definition. This would be e to the negative st times e to the negative t sine t dt. And I'll try not to put anything too crazy on the test. This one is a bit too much, but it's not going to hurt us to take a look. Let me rewrite this by combining the two exponentials, adding the exponents together. You get negative s, or let's factor out that negative, right? So we'll have negative s plus 1 times t, and then sine t dt. Okay, this is one of those by parts where you have to keep doing by parts, and then eventually you get back to where you started and you could solve out for your integral. So I'll start with by parts here. From Liate, we say that the trigs become before exponentials. So I'll make a p sine t, my dq, then I'll make e to negative s plus 1 t. Derivative dp is going to be cosine t. Integrating to get q, you'll get e to the same thing, negative s plus 1 over t, and then divided by negative s plus 1. I'll put the negative up top. So we're getting negative e to negative s plus 1 t sine of t all over s plus 1. Minus, it'll become a plus though, and I'll be able to factor out a factor of 1 over s plus 1. And then I have the integral of e to the negative s plus 1 t times sine t dt. And then you'll do by parts again on this thing, this integral right here. Okay, so again, whoops, I accidentally put in sine instead of cosine. Sorry. Okay, so this guy right here should be cosine t. All right, so Liate again tells us that's cosine t first, and then dq again will be this e to the negative s plus 1 t, and then dp, of course, will be negative sine t. Be careful with your signs. And q will be again, negative e to the negative s plus 1 t all over s plus 1. So this is where you'll end up getting kind of it looping back around on itself. So I'm going to just borrow this Laplace here and set it equal to that. E to the negative t sine t equals negative e to the negative s plus 1 times t sine t all over s plus 1. We're eventually, evaluating this thing from 0 to infinity. Anyways, then it will be plus, if you do your by parts stuff here, first it's going to be, a minus, isn't it? So it'll be minus there'll be a 1 all over s plus 1 squared when I distribute in the 1 over s plus 1. So I get e to the negative s plus 1 t times cosine t all over s plus 1 squared. I got to remind myself to evaluate that from 0 to infinity. Okay, and we'll suppose that s plus 1 is positive, so we won't explicitly say it, but s plus 1 needs to be greater than 0. In other words, s is greater than negative 1. And of course, that will be presumed in our exercises. So where the heck is this one? Here it is. S greater than negative 1 is presumed. You don't have to state that, but of course you won't be able to get your integral to work out right if you don't realize that. Anyways, then the rest of this part, right? So it'd be minus, there'd be a factor of 1 over s plus 1 from the distribution, and then another factor just from the integral. So minus 1 all over s plus 1 squared times the integral of e to the negative s plus 1 times t sine of t, which is just the Laplace transform that we originally started with. So you get the Laplace of e to the negative t sine t, right, sitting right there. And then you're going to add that part to the other side, right? So I'll end up with the Laplace of e to negative t sine t, when I factor it out, 1 plus 1 all over s plus 1 squared. Okay. I'm going to start kind of evaluating the leftover bits, all of this junk. So at infinity, both of those will go to 0. It's because you're going to use a squeeze theorem. If s is greater than negative 1, the exponential part will force both terms to go to 0 for the first part. Okay, and then you'll have minus, and you plug 0 into everything. So minus negative e to the 0 is 1, but sine of 0 is 0. So the first part is just 0. And then minus e to the 0 is 1. Cosine of 0 is 1 all over s plus 1 squared. Okay. I'm going to find a common denominator over on this left side. So what will that look like at the end of the day? Well, you have s plus 1 squared in the denominator, and then you got to put that in the numerator as well, and foiling that out and then adding plus 1. So it would be s squared plus 2s plus 1, which will be plus 2 all over s plus 1 squared. On the other side, negative 1 all over s plus 1 squared. And then multiply out e to negative t sine t. Multiplying by reciprocals, you'll just end up with 1 all over the s squared plus 2s plus 2. And you could clearly see that's the Laplace transform. Knowing what we know now, you could complete the square if you wanted to. S squared plus 2s plus 1 minus 1 plus 2, and that's 1 all over s plus 1 squared plus 1. So certainly that is what it is. From what we know about shifting on the s-axis and stuff like that. Okay. So expect, to have to do the definition, by definition, Laplace transform. You got to have all these Laplace transform memorized as well, so I may just throw at you a couple, find the Laplace transform of the function. Here's an easy one, 8t minus 11. So the Laplace of f of t is going to be, factor out the 8 from the Laplace, so you'd have 8 all over s squared. Factor out the minus 11 all over s. 16 f of t is 4t squared minus 3 sine of 5t. Laplace of that thing is going to be, well, you're going to factor out a 4, but then you need an s cubed. To think of annihilators, that would annihilate a t squared. The numerator always had to put 1 less factorial, 1 less than the exponent. So 2 factorial in the numerator. Then minus 3 times, I'm going to need a factor of 5 in the numerator, so I would have to kind of multiply by 5 over 5 and then factor out the 1/5. So you'd end up with 3/5 times 5 all over s squared plus 25. Okay, Laplace. What did I just do? An overkill? Let's see what this is. It's going to be 8 all over s cubed. I don't need that factor of 5. Sorry, I don't know what I was thinking there. So it'd be minus 15 all over s squared plus 25. Even I get them mixed up, going back and forth sometimes. Yeah, so anyways, there's that. 7.2, you start out with inverse Laplace transforms. I'm looking at questions like 1 to 22. You know, at this point, you may have to do partial fractions in order to work some of these out. Let's actually try number 14. That one's a little harder. So yeah, the Laplace inverse of 8s minus 16 all over s squared plus s times s squared plus 1. Okay. So I need to do a partial fraction decomposition of that material. So I'll come over here and do that. 8s minus 16. I'll try to avoid crazy ones, but like for this video, I just kind of randomly chose questions and I didn't know how bad or how good they would be, how easy they would be. Anyways, I will try not to put anything too disastrous on the test, but you know, every once in a while. Anyways, let's see. I factored the denominator, so I'd have a all over s plus b all over s plus 1. The last one is a quadratic, so cs plus d, irreducible quadratic in the denominator. Multiply out 8s minus 16 equals a times s plus 1 times s squared plus 1 plus b times s squared plus 1 plus cs plus d times s plus 1. I need to multiply all that junk out and then equate coefficients. So I'm going to have a times s cubed plus s cubed plus s squared. Let me get that guy. And then plus s plus 1 plus bs cubed plus s plus cs plus, I don't want to have to do millions of steps where I'm just rewriting out 50 million things. So this part right here is s squared plus s, and then I want to FOIL. So I'd end up with cs cubed plus cs squared plus ds squared plus ds, and then hopefully from this point you can kind of see the coefficients. Right, so for the s cubes, I have an a from this part, I have a b from that part, I have a c from that part. Then for the s squared, and that'll equal 0. And then the s squares, I have an a from that part, I have a c from that part, and then a d. And then for the s's, I have an a from that part, plus a b from that part, plus a d from that part, and that should equal 8. And then finally, I guess we just have a is negative 16. Okay. All right, so back subbing, I guess, a little bit, we would have, let's see, so negative 16 plus b plus c is 0, so b plus c equals negative 16. Negative 16 plus c plus d equals 0, so c plus d equals 16. Negative 16 plus b plus d equals 8, so b plus d equals, I guess that would be 24. I could solve for, I guess, b equals 24 minus d, and then substitute that into the first equation. 24 minus d plus c equals negative 16, so negative d plus c equals, seems like my numbers are snowballing. Hold on, I must have made a mistake here somewhere. I don't know, negative 0, negative 40. So then you could add this equation to that equation, and you get c plus negative d equals negative 40. So you get 2c equals, looks like negative 24. So it looks like c is negative 12, which is not right. So hold on, I must have screwed something up. Oh, I see it. This should be positive 16 right here. Sorry about that. Then what did I do? So this would be positive 16. That's not going to help. So B 20. Okay, so where the heck did I get that? That was over here. 24 minus D plus C is 16. And then you're subtracting the 24. Okay, so that would be negative 8. And then this would be negative 8. And then this would just be 8. So C, I think, is 4. 8, and C is 4. Sounds good. All right, back subbing then. B plus 4 equals 16, so B is going to be 12. And then 12 equals 24 minus D, so D equals 12 as well. Okay. B is 12, D is 12, yeah. Okay, so ultimately then what you're looking at is the inverse Laplace transform of, let's zoom out a little bit so you can see what I'm doing. Laplace transform of A, so negative 16 over S, plus B, 12 all over S plus 1. And you always want to kind of cut those CS plus D, this part of the fraction, cut that into two fractions. So you get plus 4S all over S squared plus 1 plus D is 12 all over S squared plus 1. Okay, and then we could do our Laplace inverse transform on that. So I have negative 16 plus 12e to the negative t. Factor out a 4 for this guy, it would be a cosine of t. Factor out a 12 for the last guy, and it's a sine of t. Okay, so yeah, partial fractions abound all over the place. Let's try 21. So this time we're doing solving a differential equation. Y of 0 is 6, y prime of 0 is 0. So I got s squared Laplace of y minus 6s plus 0 minus 0 plus Laplace of y is Laplace of this thing. So there's a factor of root 2. And then I have times root 2 all over s squared plus 2. Factoring out Laplace portions, I get s squared plus 1, Laplace of y equals 2 all over s squared plus 2 plus a 6s. Divide by the s squared plus 1, you're going to have our partial fractions, equals 2 all over s squared plus 1 times s squared plus 2 plus 6s all over s squared plus 1. That part's just a cosine function. And then PFD, so 2 all over s squared plus 1 times s squared plus 2 is going to be as plus b all over s squared plus 1 plus cs plus d all over s squared plus 2. Multiply through. 2 equals as plus b times s squared plus 2 plus cs plus d times s squared plus 1. FOIL. As cubed plus 2as plus bs squared plus 2b plus cs cubed plus cs plus ds squared plus d. So you have a plus c equals 0. Let's just say a is negative c right off the bat. then the squares, right? So b plus d equals 0. And then the s's, 2a plus c equals 0. We kind of already knew what was going on there. We could solve that out, right? So negative a minus c equals 0, just borrowing this thing and multiplying it by a negative 1, and add those together, you get a equals 0, so c will also be 0. B is clearly negative d. Then finally 2b plus d, 2b plus d equals 2. And substitute that in there, so you get 2 times negative d plus d equals 2. So you get negative d equals 2, so d is negative 2, and so b is equal to positive 2. Okay, then we'll go ahead and zoom out here and do our replacements. So we get y equals Laplace inverse of a is 0 plus b, 2 all over s squared plus 1, and then minus 2 all over s squared plus 2, and then plus the 6s all over s squared plus 1. Laplace inverses, so y will equal 2 sine of t minus 2 sine of 2t. Whoops, that would be square root. Then I have to kind of fix that, right? Because you kind of take this guy and you factor out the 2, and you're doing Laplace inverse. You want a root 2 in the top, right? So root 2 all over s squared plus 2, so you have to multiply by 1 over root 2. And the 1 over root 2 gets factored out of the Laplace inverse, so you have 2 over root 2 sine of root 2t. Okay, and then finally plus 6 cosine of t, and that should do it there. All right, 7.3, we get into getting the Laplace transforms of functions multiplied by t. I won't expect you to be able to do the inverses of those. I'd give you a table if I wanted that, but you should be able to just find the Laplace transform of them. And again, in 7.3, they'll kind of give you the formula in the questions. So assignment 7.3. Do they give you the? No, I guess they don't give you those formulas, but it's just you're doing a derivative, right? Anyways, number 3, we have Laplace of what am I thinking? Am I in the wrong section? Hold on. When did I get that stuff? Maybe I'm thinking of the next section. So yeah, I'm thinking of the next section. 7.4 has those derivative things in there. These are shifts on the s-axis, I believe. Okay, so anyways, number 3. Let me find where I am in my notes. Oh, there I am. Number 3 is t times e to the t plus e to the 5t squared. You got to FOIL this guy out just to see what you're dealing with. So we'll have t times e to the t times e to the t is e to the 2t plus 2e to the 5t plus t is 6t plus e to the 5t plus 5t is 10t. And you could think of them as shifted, but they're really, if you think about the annihilator, they're just repeated roots. So you would get 1 all over s minus 2 squared plus 2 all over s minus 6 squared plus 1 all over s minus 10 squared. Okay. I mean, the way you would kind of do these originally, if you remember, so like number 2, looking there, Laplace of t cubed e to the negative 8t. it's a shift on the s-axis. So you kind of get rid of this part and replace it with that, like this. You got Laplace of t cubed, where you have a shift from s to s minus -8 or s plus 8, right? Laplace of t cubed would be s to the 4 in the denominator, a 3 factorial up top, but you still have to do the shifting. And so that would be 3 factorial all over s plus 8 to the 4. So there's like two ways you could think of these as a shift on the s-axis, but I'm more likely to kind of think of them as in terms of the annihilators, a repeated root. Okay, anyways, let's look at another one. So like number 7, the Laplace inverse of 1 all over s squared minus 4s plus 5. You probably want to try think if you could factor that denominator and do a partial fractions. That would be probably the most familiar technique. But if you try to factor this, it won't work. So you're going to end up completing the square in the denominator, and then it's going to be a shift on the s-axis. So this will be s squared minus 4s plus 4 over 2 is 2. 2 squared is 4. Immediately subtract the 4 and then plus 5. So this will be the Laplace inverse of 1 all over s minus 2 squared plus 1. And so you could say, well, that's the Laplace inverse of 1 all over s squared plus 1, where there was a shift from s to s minus 2. So that's going to end up giving us, what do we want? E to the negative, my 2 looked like it died on me and became an s. E to the positive 2t times sine of t. Okay. And of course, if you get stuck, you can always think in terms of annihilators. This is like m minus 2 squared plus 1 equals 0, and then you got m minus 2 squared equals -1, so m minus 2 equals plus or minus I, and then m equals 2 plus or minus I. So that would be the annihilator for something like e to the 2t times sine of t. So you can always think of it in those regards. Anyways, let's move on to actually doing one of these differential equations, like number 15. Y double prime minus y prime equals e to the t cosine t. Y of 0 is 0, and then y prime of 0 is also 0. Okay. So in this case, I'll have s squared Laplace of y minus 0, minus s times 0 minus 0, and then minus s times Laplace of y, of course minus 0, equals Laplace of e to the t cosine t. So that's just a shifted cosine, so it would be s minus 1 all over s minus 1 squared plus 1. Okay. And then I'm going to have to factor out the Laplace. So you get s squared minus s, that's Laplace of y, equals s minus 1 all over s minus 1 squared plus 1. Divide both sides, Laplace of y. You may want to factor it because you're going to get s minus 1 all over s minus 1 squared plus 1 times 1 all over s squared minus s, which is really s times s minus 1, right? So you can get rid of some of it and kind of abbreviate the horror, but you'll end up with 1 all over s times this thing, which is really s squared minus 2s plus 1 plus 1 plus, so it's plus 2, and then you could do a partial fractions on that thing. So you would have 1 all over s times s squared minus 2s plus 2 equals a over s plus bs plus c all over the irreducible quadratic. So 1 would equal a times s squared minus 2s plus 2 plus bs plus c times s. So I'm getting 1 equals as squared minus 2as plus 2a plus bs squared plus cs. And then you could equate coefficients, I guess. So you have a plus b equals 0. Negative 2a plus c equals 0, and then you get 2a equals 1. So a is apparently 1/2. B then is negative a, which is then negative 1/2, and c will be 2 times a, which will be 1. Okay, so let's see what we got. Y is going to equal Laplace inverse of 1/2 all over s. And as usual, split up this bs plus c into 2 fractions. So you have negative 1/2, and it may not even be necessary. Let's hold off because I know I have a shift coming, so I'm going to hold off on splitting that. I apologize. Then plus 1 all over. I'm going to rewrite that denominator as it was before, s minus 1 squared plus 1. And then I'm going to pull that trick where I add and immediately subtract to that s, so it's a shifted cosine. All right, so y would equal Laplace inverse of 1/2 all over s plus negative 1/2 times s minus 1. Okay, and so I have to then immediately subtract 1/2 and then plus 1 all over s minus 1 squared plus 1, and then I'll go ahead and split that into 2 fractions. So I get 1/2 all over s plus minus, let's factor out the 1/2, and I'll have times the s minus 1 all over s minus 1 squared plus 1, and then plus 1/2 times 1 all over s minus 1 squared plus 1. Okay. All right, so that'll make it easier. Y is then 1/2 minus the shifted, so e to the negative t, or e to the positive t, sorry. E to the positive t times, it's a shifted cosine, so cosine of t plus 1/2, and that's a shifted sine. E to the t sine t. Okay. What else do we got? Laplace transforms of step functions. Okay, that was also in this section, so let's look at a couple of those. Trying to get my pen back into the original settings. Okay, number 19. Laplace of cosine of 6t, and then times the piecewise function u of t minus pi. So the trick for this is to kind of get rid of the u of t minus pi by putting e to the negative pi s. And then you're doing the transform of what's left shifted over in the plus direction. So cosine of 6 times t now plus pi. Okay. Generally, you'll want to simplify this thing. Couscous formula, cosine 6t, cosine 6 pi, and then minus 0. So that's just going to be cosine of 6t, Laplace of that. So you're getting e to the negative pi s times, it's a cosine, so it'll be s all over s squared plus 36. Okay. So no big deal there. Laplace inverse of these things then is like 22. Laplace inverse of s e to negative pi s over 2 all over s squared plus, I think my handwriting says 4. Can't read it. Okay, so what is this guy? This time you want to move this part out, and you'll have a a piecewise function of t minus pi over 2. And then it's shifting the remainder part over by pi over 2 as well in the same direction. So it'll be minus pi over 2. So instead of t, because normally Laplace inverse of this thing would be cosine of 2t, but instead of t, because of this piecewise part, you have to shift it to 2 times t minus pi over 2. So it would be cosine of 2 times t minus pi over 2. And then get u of t minus pi over 2, and then hopefully you can rewrite this thing using the couscous formula. So that's cosine of 2t cosine of pi. So that's going to give you a negative cosine of 2t. Okay, so let's try now solving one of these guys. So you have y prime plus 4y equals f of t, where f of t is a piecewise function. And then you have y of 0, and f of t is going to be t originally. It'll be turned on originally and then turned off to 0 for t greater than or equal to 1. So your first kind of objective is to rewrite f of t using those piecewise functions. So it's going to be t at first, and then at 1 it's going to go to 0. So minus t u of t minus 1. So you have to be able to fabricate those formulas. Now you do Laplace transform. So I have s Laplace y. Y of 0 is 0. So then minus just 0, and then plus 4 Laplace of y, and that'll equal Laplace of t is 1 over s squared minus e to the negative s times the Laplace of t plus 1. So you have to shift the t portion in the positive direction by 1. Okay, so you'd end up with s plus 4 times the Laplace of y, and that'll equal 1 over s squared minus e to negative s times 1 all over s squared plus 1 all over s. Okay, and then divide by the s plus 4. So you're going to get Laplace of y equals 1 all over s squared times s plus 4 minus, I don't know if I want to do 3,000 partial decomposition. So I'm going to rewrite this, I think. Well, no, I'll leave it alone. Okay, so I'll have to do 2 partial fractions. So 1 all over s squared times s plus 4. And then plus 1 all over s times s plus 4. Okay. All right, so the first partial fraction will be on the 1 all over s squared times s plus 4. That'll equal a over s plus b all over s squared plus c all over s plus 4. So 1 will equal a s times s plus 4 plus b times s plus 4 plus c s squared. So I'll have as squared plus 4as plus bs plus 4b plus cs squared. A plus c will equal 0, so a is negative c. 4a will equal 0, so a will equal 0, so c will equal 0. That is not right. I screwed something up. Jeez. What did I do wrong here? Squared plus 4as, so a plus c is 0. 4a, it's 4a plus b. Sorry guys. So 4a plus b, 4a plus b equals 0. Okay, so I guess 4a equals negative b. So what do I have? This guy, this guy, this guy, and then I already got that guy. So 4b is equal to 1, so b is 1/4. A is negative 1/16 then. That took a while. And then C will be positive 1/16. Okay, so that's one partial fraction. The other one, I need 1 all over s times s plus 4, which is a over s plus b all over s plus 4, which is 1 equals a times s plus 4 plus b times s. Let s equal 0. You get 1 equals 4a, so a is 1/4. Let s equal negative 4. You get 1 equals negative 4b, so b is negative 1/4. Let's go out and see what we have. So y equals Laplace inverse of, the first portion is negative 1/16 all over s minus 1/4 all over s squared plus 1/16 all over s plus 4. Then minus e to the negative s of kind of the same beeswax, negative 1/16 over s minus 1/4 all over s squared plus 1/16 all over s plus 4, plus this new part, 1/4 all over s minus 1/4 all over s plus 4. Okay, I can combine some of that material. Let's get the first part of the inverse Laplace done though. 1/16 minus 1/4 t plus 1/16 e to the negative 4t. This part will give me a piecewise, right? So minus u of t minus 1, and then I have to put t minus 1s on all of these elements. So anyways, I could combine some like terms here. So negative 1/16 s plus 4/16 s is 3/16 s. Okay, so from that I'll have 3/16, just 3/16. So that gets rid of these guys. And then there's 1/16 all over s plus 4 minus 4/16 all over s plus 4 will give me negative 3/16 all over s plus 4. So minus 3/16 e to the negative 4 times t minus 1. And then finally, I got rid of those. Finally, I just have a t, right? So minus 1/4 t minus 1. Yeah. Seems like I screwed up one of my terms. Seems like I messed up a sign here. Hold on, let me find it. Oh, I found it. I'm not going to like that. This is right here. So this would be positive. This would actually be positive. And I think that'll do it. Okay, so this guy is positive. And then the s squared part is what's changing. So that would be positive. Was that it? Hold on, let me make sure. No, it's right. I actually have it wrong in my notes. So, I did it wrong in my notes, but I got it right here. So let me fix my stupid notes. So 1/4, and then plus minus on that one. Sorry. Okay, great. So let's move on to 7.4. That's where we were looking at Laplace transforms of like a multiple of t times like e to the t. And the way to get your Laplace transforms by taking derivatives. But you know, the questions will give you kind of that formula, so it shouldn't be that hard to do those. Anyways, a question pool for those. And 7.4. This thing over a little bit. 7.4, we're looking at problems like 1 to 4, and then 8 to 21. Okay, so in particular, number 4, we have Laplace transform of t, e to the 2t sine of 5t. And so you basically are taking the derivative of the Laplace transform of that part I just put in the box. Okay, so it'd be negative d with respect to s of, and that thing's a shifted version, right? So you need a 5 in the numerator, and then s minus 2 squared plus 25, right? Okay, let's rewrite it easier, so it's easier to do a power rule on. So I have 5 times s minus 2 squared plus 25 to the negative 1. Bring down the power negative 1, so it'd be positive now. 5 times the guts to the new exponent is negative 2 times the derivative of this material. That would just be 2 times s minus 2 plus 0. And then you can write up your answer. So it'd be 10 times s minus 2 all over s minus 2 squared plus 25 squared. Okay, but like I said, they in this section they kind of give you that equation. Where was it? 7.4. The inverse Laplace of those, I'm not going to expect you to do those. You would probably need a table, and actually in the homeworks they expect you to kind of use tables on those type of problems. But you know, for the first kind of problems, I'll give you the formula just like they do in the question. Then for problems like 5, I'm not even including those on the test because you would have to use that table, and I don't want to use the table. Okay, I want you to do it all from memory. Okay, then we get in the convolution. So the Laplace of the convolution, all you got to do is take the product of the Laplace transforms of the functions. So for example, number 10. Example number 10, we have Laplace transform of t squared convoluted with t e to the t. So all you have to do is take the Laplace of t squared, that's s cubed with a 2 factorial up top, and then times this other thing, which you could think of as, you know, a shifted version of t, or you could just think of it as a repeated root with respect to annihilators. So it would be s minus 1 squared, the 1 on the top. Okay. Let's look at another one. So this 13. So this is written in the literal form with the integral e to the negative tau cosine tau d tau. So I guess you kind of have to have that part memorized. The Laplace of a convolution, or just what is a convolution. The convolution is the integral from 0 to t of f of t minus tau times g of tau d tau. So in this case, the g of tau maybe not so apparent, but it's the e to the negative tau cosine tau. And then the f part is just 1. Okay, so you're doing the Laplace transform of 1 convoluted with e to the negative t cosine t. Okay, so the Laplace transform of 1 is just going to be 1 over s, and then the Laplace transform of the other part is just shifted cosine, right? So you're going to get s plus 1 all over s plus 1 squared plus 1. Okay. Let's solve one of those integral problems, integral equation. So try like number 18. I'm not going to put any of the periodic ones on the test. I probably have to give you a formula for that. I'm not big on giving out formulas during tests. So let's go to 18 and take a look at one of those. So I have f of t equals t e to the t plus the integral of tau f of t minus tau d tau. Okay, so we'll have Laplace of f of t equals this 1 all over s minus 1 squared plus Laplace of this thing, which is a convolution of, looks like it's just t and f of t. Okay, so you can rewrite this, Laplace f of t equals 1 all over s minus 1 squared plus Laplace of t is 1 over s squared, and then you have times the Laplace of f of t, and then you solve for the Laplace of f of t. So you're going to get the Laplace of f of t times 1 minus 1 over s squared, and that'll equal 1 all over s minus 1 squared. So you have the Laplace of f of t. This will be finding common denominator. I have 1 all over s minus 1 squared times, looks like s squared all over s squared minus 1. And I don't think there's any way around having to do an obnoxious partial fractions here. You could try like turning this into a convolution, but I don't think it's going to be all that much easier. So we'll just go at it, look for the decomposition. So at the end of the day, s squared minus 1 is s minus 1, s plus 1. So you're going to get s minus 1 cubed times s minus 1. And then I'll go after the partial fractions of that nightmare. Okay. And it's going to take a couple minutes. So put on your partial fraction hats and maybe go grab a pop or your beverage of choice. So what do we have then? We have s squared all over s minus 1 cubed times s, that should be a plus 1 right here. Alright, so this would be a all over s minus 1 plus b all over s minus 1 squared, c all over s minus 1 cubed, plus d all over s minus 1. So s squared is going to be a times s minus 1 squared times s plus 1. And if you don't mind, I'm just going to write out what that is. I'm going to cheat a little bit for you. So s cubed minus s squared minus s plus 1. And then plus b times s minus 1 times s plus 1, so that would be s squared minus 1, plus c times the part that's not there, and there should be an s plus 1 there. So it would be s plus 1, and then plus d times s minus 1 cubed. And if you remember your Pythagorean triangle or whatever it was, this thing, Pascal's triangle, sorry. We need this row, so s cubed, and then negative 1 to the first power is going to give you a negative 3s squared, and then negative 1 squared is plus 3s, and then negative 1 cubed is negative 1, so you get that object. Then we could start equating. So the s cubed parts, we have a plus d equals 0. So a is going to be negative d. The s squared parts, I get negative a plus b minus 3d equals 0. So it looks like I have negative a plus b plus 3a equals 0. So 2a plus b equals 0. So that's the s squared parts. The s parts, oops, that equals 1, right? Because the s squared is, there's one of those on the left side there. So it's all equal to 1. What else? The s portions now. So we have negative a plus c plus 3d equals, this time definitely 0. Let's maybe make this a little less complicated. xa plus c minus 3a equals 0, so minus 4a plus c equals 0, so c equals 4a. And then finally the a plus minus b plus c minus d equals 0. So we get a minus b, c is 4a, and then negative d is just 1a equals 0. So 4, 5, 6a minus b equals 0. I'm going to add that equation to this equation, so I get 6a minus b equals 0, and that give me, I'm already adding it, 8a equals 1, so a equals 1/8, and then d will equal negative 1/8, c will equal 1/2, and I don't have a formula for b anywhere. Of course not. B is equal to 6a's, so B will be equal to 6/8, really, which is 3/4. Okay. Okay, so let's zoom out and see what we're dealing with. So f of t is going to be a Laplace inverse of a, where are you, a? 1/8 over s minus 1 plus 3/4 all over s minus 1 squared. You think of those as translations on the s-axis if you want. This is going to be a 1/2 s minus 1 cubed, and then plus negative 1/8 all over s plus 1. Okay, so f of t is going to be 1/8 e to the t plus 3/4, and I'm just going to think of them as kind of annihilating repeated roots. So t e to the t. This last guy, though, you really have to be careful. Technically, you're doing 1/2 Laplace inverse of 1 all over s cubed, where s is being transferred into s minus 1 territory. So that would be 1/4 Laplace inverse of 2 factorial over s cubed. So s goes in the s minus 1. And so you have the 1/4 of t t squared. That was way harder than it should have been. T squared, and then e to the t to get rid of that shifty part. Okay, so plus 1/4 t squared e to the t minus 1/8 e to the negative t. And that should do it. So just be careful with those little things. Let's now go to 7.5, and there's only like 7 questions, so I'll just pick one of those. Let's get back into the usual. Okay, so number 2, you have y double prime plus y, and the Dirac delta function on the other side, t minus 2 pi. And then y of 0 is 0, y prime of 0 is 1. So we're going to get s squared Laplace of y minus s times 0, which is 0, minus 1, plus Laplace of y equals e to negative 2 pi s. So we're going to get s squared plus 1 Laplace of y equals e to negative 2 pi s plus 1. Divide by s squared plus 1, so get Laplace of y. This one's easy. E to the negative 2 pi s all over s squared plus 1 all over s squared plus 1. And then do inverse Laplace, so y equals, there will be a piecewise function here, t minus 2 pi, and then sine of t, but you have to go minus 2 pi. and then plus sine of t. Let's clean this guy up with the same sine formula. So that'd be sine of t cosine of 2 pi. So that's just going to be sine of t. So we're going to get sine t times u of t minus 2 pi plus sine of t. Sorry about my handwriting. And that'll do it for me, and thank you for watching, and good luck on the test, and I'll see you next time.